and y is less than equal to b. This is to show. Everybody with me? Yes or no? Now what do I do? Right. So we have not used the fact that f is convex. Hey, you should have stayed there if more students are coming. Stay there, na? If they'll keep searching for me, then they'll not find me. Is Kuldeep recording? Kardi? Okay. So those who came late, I'll start again. We're finishing the convexity discussion from last time. The problem we had was fx is given as convex and given a set L where fx is bounded by B. You had to show that this set L is convex. To show that it is convex, what do? We take any 2 points in the set and show that the line connecting the two, all the points on that are in the set. So if x and y is in the set, means fx is less than b, fy is less than b. To show alpha fx, alpha x plus 1 minus alpha y is in L, or f of alpha x plus 1 minus alpha y is less than equal to b. This is something we have to show. Now, like he said in the green shirt, we have not used convexity. What's your name? Tanish. Okay. Like Tanish said, we have not used convexity. So we're going to use convexity on this. Everybody with me? So we'll take the left hand side of 1. F of alpha x plus 1 minus alpha y bounded by, what is the definition of a convex function? Alpha times of f of x plus 1 minus alpha times of f of y. You have seen this definition the first time. If you're not remembering it, don't worry, you'll remember it in a day or two. You just have to keep the mind that the function value is below the line or the surface connecting the two. Now what do we do? What do we know? We know that f of x is less than equal to b. Convexity though we have used. So we'll use this equation now. F of x is less than equal to b because x is in L. Correct? So alpha times f of x would be less than equal to alpha b. Correct? Yes or no? Sorry, this is not a vector. It's a scalar. Because f is scalar. This is less than equal to alpha b. Plus, if f of y is less than b, then 1 minus alpha times will be, f of y will be less than 1 minus alpha times b. Yes or no? Why? Because alpha is also positive and 1 minus alpha is also positive. If it was negative, then we were in trouble because then the inequality will switch. Alpha f of x is less than equal to alpha b and 1 minus alpha f of y is less than equal to 1 minus alpha of f of b. Sorry, not f of b, just b. Because alpha belongs to 0 and 1, it's positive. So 1 minus alpha is also positive. So you can put this in this inequality. Is everybody with me? So we substitute that 1 minus alpha b. Now what do you get? Alpha b cancel out. So you're left with b. So hence this is equal to the right hand side of 2, which you wanted to prove.
So this is not circular reasoning. We are assuming f is defined on alpha x plus 1 minus alpha y. That implies that it lies on the set in which f is defined. So we are defining that thing to be convex.
Sorry. What's your question?
I'm asking if this is not circular reasoning, because when you say f of alpha x plus 1 minus alpha y is less than that million, or
No. Well, yeah, in one sense, correct, because convexity is always defined on a convex set. So, yeah, in that sense, this is circular. What's your name? Hmm? Abhinav. So, what Abhinav is saying is that the convexity of a function is always defined on a convex set. So, there is an implicit assumption that if you're acting it on L, then it is a convex set. That's what it's saying. But don't read it into too much. Usually we don't prove convexity of a set. We rather prove the function is convex or not, which we saw in the previous problem. Is that okay? Yes or no? Okay. All right. So let's say yeah, you're right. This had to be convex set. So in that sense, this is redundant. Okay. So now what we'll do is we'll go back to our automatic differentiation. Any doubts on this? No doubts? You'll do more problems on this on Wednesday on in the tutorial on convexity. Okay. So in case you have doubt, you can ask me. Okay, so we go back to tutorial 3, which we started at the start of the class. So we had done the first problem on auto diff that time. Then there was this third problem on Hessian, which you computed. And at the start of the class, we talked about the Taylor, the multivariate Taylor. Okay. So then what I did was, based on your doubts in the first autodiff question on Wednesday, I decided to create this new problem because I thought you will get confused a little bit on how to read the graph. So that's why I created this, but the way I executed it in the morning, it led to more confusion. So we are just doing it from the scratch now so that you don't get intimidated by autodiff. Is that okay? So the problem which we were working on was f of x is equal to x cube plus e to the x cube plus ln, which is log of x cube plus e to the x cube. Okay. So this is the problem. And if I had to take the partials of this, we'll first do the partials so that we can match with autodiff. Like he said, what's your name with the glasses? Huh? Sri Chand. So like Sri Chand said that we should match, always check what's going on. And so if I have to do df over dx, let's just write it down for the sake of it. Then we'll do autodiff. So this is 3x square. You take partial of this, it will be 3x square e to the x cube plus 1 over x cube plus e to the x cube times again 3x square plus 3x square into e to the x cube. Can everybody do this? Simple chain rule. So you can pull all these terms out. So 3x square can be pulled out. Then it will be 1 plus e to the x cube will also be pulled out, and you'll be left with 1 plus 1 over x cube plus e to the x cube. Everybody okay? I just pulled it out. This is just to verify that what we are doing is correct or not. Okay, so now we'll do the autodiff. So the very first thing to do in autodiff is to define the variables. So we defined a is equal to x cube, b is equal to e to the a, c is the sum of these two, which is a plus b. Then we say d is equal to ln of this plus this, which is ln c. And then we finally, we can say, I'm writing f, although you can write e also. is equal to C plus D. Yes, this was straightforward. Now we have to write the partials of these. So we're going to write the partials of these. So dA over dx is equal to 3x square. dB over dA is e to the a. Now is the tricky part. So dA dc over dA is equal to 1 because we not considered the dependency here, which is also equal to dc over dB. Okay. So the question which these guys had asked me why I brought this question today was, if you consider this to be a function of a, then you would write dc over dA as 1 plus what? This is e to the a, right? So this will be again e to the a. So this will be written as this. Because b is e to the a, it will be a plus e to the a, which will be 1 plus e to the a. Right? Everybody with me? This is how you would read. I'm not saying read it backwards, but I'm just emphasizing a point which you'll see in a minute when we come to the graph. So we go down slightly. Again, d over dc is 1 over c. And then df over dc is 1, which is equal to dd over, sorry, df over dD, or again if you consider d to be a function of c, then it will be c plus ln c, right? And then when you will differentiate, then df over dc will be 1 plus 1 over c. Agreed? So the question which these guys were asking, how far do we go back? That is what we were saying. Should we stick to this dc over dA or this dc over dA, this df over dc or this df over c? So what do you think? What, Tanishq? Sorry? We just avoiding the confusion because everything is dependent on x eventually, so we don't want to worry about which is partial, which is not. Safely write everything as a partial. That's why we are writing. Is that okay? So Tanishq, sorry, what is getting confusion? Mm-hmm. Mm-hmm. Sorry? If it makes you happy, you write dc over dA. That's okay. I am just writing partials because I don't want to get into the full or partial derivative. You can write this as dc over dA. It shouldn't matter for me. The point which I'm trying to emphasize is something else which is more important than just the notation here. Tanishq, why, tell me now. Which one should we carry? Should we carry this derivative? Since we are spending so much time on this and the book is not clear on this, so that is why I've taken a different example, or should we carry this? Yeah, Tanishq, tell, you did already. No, Tanishq, I'm asking again. Ramchandra, I'm referring to him, Tanishq. Ramchandra? Sorry? Shri Chandra. Okay, sorry. Okay, Shri Chandra, yeah, tell me. Which one should we carry? And how far should we carry? Everybody agrees this is a point of confusion? First you agree that there is something missing, then we'll solve it. Huh? Okay. Hmm. Okay. Okay. So, Okay, fine. So, all right. So, I'm just seeing where you're thinking. So, what I'm trying to tell now is in automatic differentiation, we will not do this. We will not go backwards. We'll not go beyond the line we are there because we'll let the graph figure it out. So the graph reading, now we go there, we'll check this whether we're doing it correctly or not correctly. Everybody with me till this point? Okay. So let's now draw the graph. So you can draw it many ways. The way I have drawn it. X cube. And this is A. Then E. And then you get the B. And then you add the two. And you get the C. This is ln. Get the D. Then you again add it. Get your F or E, whatever you want to call. Everybody had drawn the graph, so I think till this point it's okay. Now is the important part of reading the graph. So in reading the graph, if there is the node which is adjacent to your final node which you're trying to compute, and there is no other path to it, a backward path, then you directly know that there will be a derivative existing. In this case, df over dd is already computed, and this is fair enough, it's there for you. So the tricky part is, which I think he was doing correctly, and I should write this as well, is when you write df over dc, then I would write this over this, and this. There are two paths reaching C. Everybody with me? So I will write this as df over dc, sorry, dd, and then dd over dc plus a direct df over dc. If I substitute this, so df over d is 1, dd over dc is 1 over c, plus df over dc is 1. So this is 1 plus 1 over c. Because you're reading this backwards here, plus a backward here, because there are two paths reaching C. Everybody okay? In the earlier example which we had done, we just had, if you remember the first example which we did in the class, this was f plus and this was f here, and we had two paths going there. So we had done both of them here. So the same thing has to be done here. And if you look at this, if you had not considered this, so this becomes equivalent to, in case you had written this guy, which means that you would ignore this path. You will just, this is equivalent to this, that you have substituted f is equal to c plus ln c, and then you are writing df over dc, or if Tanishq is happy, we can write as df, complete df over dc is 1 plus 1 over c. In that case, we ignored the d and we substituted c. In that case, it comes out 1 plus c. But since we are carrying the d as the intermediate variable, I would ignore this because I am considering this path, which is ln d and added. So this path is making us not worry about a backward in the equation because the graph is reading this. Is it making sense? Shri Chandra? No, Shri Chandra. And okay, this time I shouldn't say it wrong. Is that correct? Next to you is? Huh? Next to you? Sanjay. So Sanjay, you were writing it correct. In the notebook, you were writing this. So you were reading the graph correctly. So keep doing what you were doing. Is that okay? Anybody else who was writing like this? Yeah, so you're doing it correctly. So stick with that because graph reading has to be done through all the paths. We'll emphasize this again one more time. Is that okay? Are you getting lost? What's your name? Sunita. Are you getting lost? Okay. You smile more. You look so stressed out. I stress out looking at you. All right. Keep smiling so that I know that you're getting it. So everybody okay? df over dc. Why we are not going backwards in the equation, but we are rather going backwards in the graph. Okay. Huh. This is an earlier equation. It is like adding up in a for loop, no? Huh. No, these are different. No, this dou f by dou c we have read from here. The earlier stored value of df over dc. Both are same. It's a earlier value. This is the final value. You're doing it in iterations. It is something like this. Initially a was 0, but then you added a and the final a which you will print here, or is equal to 3 in this case. So initially it was 0, 1 got added, then another got added, it's 1. So this is the initial value of df over dc. You added this loop to this and then you got the final value which is equivalent to the value in case you had not used the substitution variable d. Is it making sense? Any more confusion? Ask me before I move forward. If you have doubts, then ask me. All right. So this was the first loop which we went for backward. Now let's go another loop backwards. df over, we have to reach b. So to reach over b, which node we have to worry about is, since the node which we calculated was c, you can read it this way that nothing else exists in between. There is somewhere these are connected. So the node which is just before b is the c node. So you will read this as df over db is df over dc and dc over db. df over dc is coming from above, dc over db is 1. So this is nothing but df over dc times 1, which is 1 plus c, 1 over c times 1. Yes? Everybody with me? Let's read it further down. क्लास तो नहीं है 12 o'clock, free है ना? Okay. So we go further. Now we have to go is A. To connect A, we have the B node and we have the C node. So df over dA. So the way we did it in class was Hardik had asked. So we had done it as df over dc, dc over db, db over dA. This was one path, and then it was the straight path plus df over dc and dc over dA. Correct? This is what we had done. So now what I am trying to say here is that since you have already computed df over db, you did not write dc over db, db over da, because df over dc, dc over da, because this thing is df over db and db over da plus df over dc times dc over da. Or rather than going through C, since we have already computed B, we can say that there is some connection. We don't worry about it. There are two nodes before it. There are two nodes before A. There is a B node and there is a C node. So now we'll just worry about that. Rather than doing the long step, we'll just write. No, why does this go away? How to reduce this size? How to reduce the zoom of this? Sorry? View, acha. Oh, sorry. I wanted both the things written together actually, the graph and this. Okay. Yeah, this is fine. Thank you. So now what I'm saying is, instead of worrying about df over dc, c over b, b over a, since we have already computed df over db and we have computed df over dc, we just go read from these two which reach a. So we'll say df over db into db over da plus df over dc and dc over da. Is that okay, Hardik? Where are you? Yeah, so the point was that you don't have to take the intermediate path. We just, because we have already read df over db and df over dc, we assume that nothing else exists. Instead of worrying about this connection and going this way, we already have df over db, so we read it this way. Everybody okay? Yes or no? Okay. So we'll substitute these values now. So these values are df over db is 1 plus 1 over c into 1 times df over da, which was, sorry, db over da, which is e to the a, plus df over dc is this now, 1 plus 1 over c. What was your name with glasses? Huh? Chanikesh. Chanikesh. Is this a shorter name? Mahi, yeah, that's better. So what Mahi you were asking, now when we're putting df over dc, we'll put the final value of df over dc, not the initial value, because the initial value was used and you got the final derivative. Does everybody agrees? This is the final value of df over dc. So this into dc over da, dc over da is 1. So this is 1. So this becomes 1 plus 1 over c into 1 plus e to the a. And now finally we'll compute df over dx. To read that, what I'll do, I'll assume that nothing else exists. I'm just erasing it for the sake of you. Because till df over da we have already computed. So now this will be df over da, which we have computed, into da over dx. Correct? df over da already we know, 1 plus 1 over c, 1 plus e to the a, da over dx is 3x square. 3x square. Now you substitute the values, 1 plus 1 over x cube plus e to the x cube times 1 plus e to the x cube times 3x square. So this is your final answer, which is exactly what we saw earlier. Everybody comfortable? Any doubts? Any confusions? If there is no doubts, no confusion, then I'll confuse you one more time so I can bring you back in. Okay. So note. So what you have seen with me is that, let me draw the graph back again. I'll not leave you until I make sure that you understood this. See, going. It's positive. This was a B added, this was a C, there is an ln, there is a D, added, there is an F. Okay, so everybody agrees with me that if we had written df over dc as 1 plus c or d as a function of c, then I would have not needed this graph. This graph is taking care of that. The question is, where is this being taken care of in the computation? This, you agree, is taken care of this graph. Where is this taken care of in the graph? Who answered? Yeah, Sri Chandra. Right. Yeah, so why is 1 plus en not evident here? Because this loop is taking care of it in this step. Okay, if you've written it, then I'll erase and show you again. Everybody is okay till this point, no? I don't want to confuse you, but I want to emphasize this one more time. So let's erase all of this. Okay, so now erase this also so that you don't get confused. Okay, so now when I'm going backwards, df over dA, again I'm going here. Then I had already said just consider B and C and do this, but in case I was taking all the paths backward, so this was df over dc, dc over db, db over dA, this was one path, and this was the other path, df over dc and dc over dA. Okay, so now if I keep the df over dc separately, c over b, what you have computed earlier is, c over b is 1, yes? Yes or no? So I substitute that, times b over a is e to the a, plus FCF taken out forward, c over a, again I am substituting it as 1. So this is nothing but df over dc into 1 plus e to the a. So this 1 plus e to the a is this dc over dA, and if this thing was not considered, if this guy was not there, then I would call with the substitution this guy as dc over dA. Now read the graph, hai na? If this was not there, df over dc, dA is df over dc into dc over dA, and dc over dA is 1 plus e to the a, because the intermediate b you have removed. Can everybody see it? This was just to re-emphasize the same thing, that when you go here, don't go backwards. Keep it simple at that level itself. Don't make it as a function of function. Let the graph reading take care of it. Abhi clear hai? I'll write it down neatly and upload it again in the tutorial. If you have any doubt, go over that and then you can ask me tomorrow or Wednesday again. But I don't want you to get confused on autodiff. This is the slightly tricky topic in this section. That's the only tricky topic. That's why you got confused. Everybody okay? So now before you leave, what I want is feedback. Because I am not getting how much you're getting my class and how much you're not getting. So I need to know. So take a sheet of small paper. You have paper, you can take it out from your notebook behind it. Because tomorrow then we'll be short of time again. So we'll not have enough time. Just I want to, because we are almost half of what I am going to teach. It's not half of the semester, quarter of the semester. So 3 weeks are done, 3 more weeks are left. So I want to improve and make sure that you get what I say. So just take one small sheet. You can take 4 parts and give it to your neighbors. What I want you to write is what you feel is going okay, which I should retain, and what you feel is not going okay. If the tutorial is not going okay, you tell that. If the pace is too fast, you tell that. If the writing is not good, you tell that. Whatever you feel will make your. Don't write about jokes. Sometimes I get a comment that there should be more funny jokes. I know that I don't spend time finding jokes, so that's why. But about the class, what can improve your instruction and what make your learning better, that write that part, and write something. What is okay, what can be improved, है ना? कुलदीप कहाँ गया? अच्छा रिकॉर्डिंग बंद करने क्या हुआ? And before the quiz is on 21st, है ना? But 19th we are keeping it off because we took an extra tutorial, so we are not doing anything on Rakhi Day in case you're traveling. 20th I'll take a class, है ना? Whatever will be there in 20th will come in the quiz, है ना? So do come on 20th. So it's not that until today or tomorrow will come in the quiz. What I'll teach on 20th, which will be the last of this vector calculus and optimization, that will come in the quiz. And about this auto diff, we'll add